Hi everyone. Um, if you had problems with the exit ticket part 2 on linear modeling where you had to write the equations, this video will help you and give you some extra practice with that. At the end of this document, there are two problems that you may do to replace your previous score on the exit ticket. So I'm going to go through some examples. If you get it and you don't need to go through them all, then you may stop this video and start working on the two problems. Make sure that you submit them either on paper or written with all of the steps so that you'll get credit for the 4 points for the exit ticket quiz score. Okay? So the first thing, we're writing equations, and the two at the beginning that I have up here are just review. If you look at the side over here, y equals mx plus b is what you're going to be using this entire time. So remember, there's two parts to that. There's your slope and your rate, or your average rate of change, which is m, okay? And then there's b, the y-intercept. Now, when you're doing a word problem, slope and rate, you'll see words like per or each, okay? It's a cost that repeats depending on the number of items that you have. And then for y-intercept, you're going to see words like it's the fee or the one-time cost. So it's the amount you pay regardless of how many items you buy or use. You're always going to pay that fee. Okay? So when we look at number one, it says you rent a bicycle for $20 plus $2 per hour. So right away, you're going to notice the word per. Okay? So that means that this is going to be my rate or my slope. And then the one-time fee is the $20. So that's B, my y-intercept. So if I want to do an equation, okay, y equals mx plus b, I have two variables I have that I have to fill in, m and b, okay? So y equals 2x plus 20. And so I have my equation already written. In this case, they didn't really tell or give us variables to use. So if I look at what they are, X is going to be, since it's $2 per hour, it's going to be the number of hours. Okay. And then Y, my equal to answer is going to be the total cost. So in this case, the total cost to rent the bicycle. For number two, an auto repair shop charges $50 plus $25 per hour. Okay, so if you're getting your car fixed, you always have to pay $50. So that's your one-time fee. B, and then you pay $25 per hour, so that's your rate. That's your M. All right. So if we look at our equation, we have y equals 25x plus 50. Okay. And now we can look at what our variables are. Our x, notice it says per hour again. So x is number of hours. And then y is going to be, if we're paying for it, it's going to be the total cost or the total cost of repairs. So a lot of these follow similar patterns to this. And the more you do, the better you will get at it. The first problem example that I have here, that besides the ones at the beginning that were quick, is the actual exit ticket that you did. So the total cost of an order of shirts from a company consists of the cost of each shirt. See that word each there? Talking about rate here. M plus, so plus a one-time fee, design fee. So there's your B. The cost of each shirt is the same regardless of how many shirts are ordered. So we're looking for an M and we're looking for a B. And then they give us information. The company provides the following examples to customers to help them estimate the total cost of an order. 50 shirts cost $349.50. 500 shirts cost $2,370. So we have to use this to find our rate, and we have to find our y-intercept. So for A, it says, based on the examples, what is the cost of each shirt, not including the one-time design fee? So we're finding M, okay? What is our rate? Well, all that's given to us are two things, and those can actually be written as points. 50 shirts cost $349.50, and 500 shirts cost $2,370. So we have 2 points. And if you remember, in order to find rate from 2 points, we use the slope equation. So I'm going to write that up here. Y2 minus Y1, X2 minus X1. So we're going to use that to do this. So I've got, let's do X1, Y1, X2, Y2. I'm going to use my slope equation. Okay. So I'm going to do Y2, 2,370 minus Y1, 349.50 over X2, 500 minus X1, 50. Now I'm just going to do the subtraction. We get 2020.5 over 450. Okay. And then from there, I can divide those, and I end up with 4.49 or 4.49. So if I look back, it says, what is the cost of each shirt? Okay, so this is my answer. It's actually $4.49 per shirt. And I explain my answer by finding the slope. Okay, so let's go down to B. What is the cost of the one-time design fee? Well, now I have the $4.49. Okay, so I know it's $4.49 per shirt. And then I need to find the design fee. So let's just pick one of our points. For example, we know that 50 shirts cost $349.50. And we can use these to find the one-time design fee. So if I'm looking at this, I got 50 shirts. Okay, so I'm going to do $449 times 50. I need to find out how much I spent on shirts, which comes out to $224.50. However, the total bill was this $349.50. So if I spent $349.50, but the shirts only cost me $224.50, what is left over? $125. So what is the design fee? The design fee is $125. So that's where I get both my slope and my y-intercept, which is going to lead us into the last problem. Write an equation in slope-intercept form for the total cost of an order of shirts, y, as a function of the number of shirts, x. So they told me what I need to use. And I'm using y and x, so y equals mx plus b. I already found above my m and my b. Okay, my m was step A, 449. My B was step B, 125. So when I write my equation, y equals 449, oops, x plus 125. And that's my equation. So you actually, this was exit ticket part 2, the original one, and I just went through it with you so that you can see what to do. Okay, so I have a few more examples that we're going to go through right now. So let's look at the next problem. Okay, so a small appliance manufacturer finds it costs $9,000 to produce 1,000. Oh, sorry about that. To produce 1,000 toaster ovens a week, and 12,000 to produce 1,500 toaster ovens a week. So the first question is, what is the slope of the graph average rate of change, and what does it represent? Well, I need to look at what are my 2 points. Okay, so 9,000 for 100 toasters, 1,000 toasters, and 1,200 for 1,500 toaster ovens. All right. Now I want to actually look, and I'm looking ahead a little bit at C. We're going to end up expressing this as a cost. How much does it cost for a number of toasters? So I do have 2 points. Okay. But what is changing? My toaster ovens are changing. Okay. So the number of toaster ovens is changing. So that's going to be my x variable. So when I write these 2 points, I've got 1,000 toasters for $9,000. And then I have 1,500 toasters for 12,000. So those are my 2 points. Okay? And I'm going to use the slope equation. So I'm going to do y2 minus y1 over x2 minus x1. And you don't have to label, but I'll label them up here. There's x1, y1, x2, y2. And I'm going to fill that in using those numbers. So y2 is 12,000 minus y1, 9,000 over x2, 1,500 minus x1, 1,000. Do the subtraction, I get 3,000 on the top, 500 on the bottom. 3,000 divided by 500 is 6. So 6 what? Well, it cost, if I look at the actual numbers, the top number is the money, and the bottom number is the number of toasters. So it costs $6 per toaster. All right, and it asks, see how it says, what does it represent? So $6 per toaster. I could also write it is $6 for 1 toaster. Either way, I'm showing what that represents. Okay, now what's the y-intercept of the graph, and what does that represent? Well, I need to go back and think about, okay, it's $6 per toaster, right? And then what else do I have to pay for? Well, let's look. We can pick either one. Let's pick the first one. 1,000 toasters. or toaster oven costs $9,000. Okay. Well, if each one's $6 per toaster, right? I'm going to do 6 times 1,000. So I spent $6,000 on toasters. But the total cost was $9,000. So I need to find out what's the difference between the $9,000 and the $6,000 for toasters. That's $3,000. Therefore, okay, the y-intercept is 3,000. And what does that represent? Well, it's going to represent the fee to produce toasters. We can put this anyway. We can say is initial fee, one-time fee, to make the toaster or toaster ovens. Okay, now we're going to express the cost as a function of the number of toasters produced. We're going to assume that it is linear, so we're using y equals mx plus b. Okay, so my y equals, my slope is at $6, and my y-intercept, I just found above, is 3,000. So what do those variables represent? Y is the cost, or total cost. X is the number of toasters. Okay, so you should see that this one was very similar to the one above it. Let's go down about the bus company. So a bus company took a tour bus on the ferry when there were 30 people aboard. The ferry charged the bus company $180. The following week, the bus had 50 people on board, and the ferry charged $220. And they want to know how much does each person cost and what does it represent on the graph. So I have, once again, I know 30 people is $180. And I know 50 people cost $220. So if I'm looking for how much does each person cost, I'm looking for my slope. I'm looking for my rate, my average rate of change. So I'm going to use my slope formula. y2 minus y1 over x2 minus x1. I can label them again, or I can just go in order. I'm subtracting 220, my y's, minus 180, over my x's, 50 minus 30. So that ends up being 40 over 20, and 40 over 20 is 2. Well, what is that? They kind of already told us way up in the problem. How much does each person cost? Okay, so it's $2 per person, and on the graph, it is the slope. Okay. Now it says, what is the base rate for an empty bus? This is another way of saying one-time cost, one-time fee, and what does it represent on the graph? So I need my base rate. So let's pick one of the points. 30 people is $180. I know that every person is $2, right? So $2 per person. So if I have 30 people, I'm going to do the $2 times 30 people. That's 60. But that wasn't the cost of the bill, right? The cost of the bill was $180. So I've got to take the 180 down here. Oh, excuse me. Apologize. Sloppy. I'm going to do 180 minus the 60, and that means it's $120. So what's the base rate? The base rate is $120. And what will it be? Well, it's going to be where my graph starts, or it's also going to be called my y-intercept. The y-intercept of my graph. Okay? And now you're going to notice, so I have a slope, I have a y-intercept. So express the monthly cost, y, as a function of the miles driven, x, assuming that a linear relationship is suitable. That just means I can use y equals mx plus b. I'm going to use y equals mx plus b. That's linear. My slope is a, 2. My b is b, 120. Now I'll write my equation, y equals 2x plus 120. Okay, you should start seeing a pattern. I'm going to do one more example. If you need one more, it is also similar. So the monthly cost of driving a car depends on the number of miles driven. Lynn found that in May it cost her $380 to drive 480 miles. And in June it cost $460 to drive 800 miles. Okay, and we know we're going to have to find the slope, the y-intercept, and then notice C down here, express the monthly cost, C, as a function of the miles driven. Okay, so we have cost and we have the number of miles driven. So I need to write these as 2 points. So 480 miles cost $380. So you should start noticing the x value is always what's changing, and the y value is the result. So when the miles change, so when the mile changes to 800, the result is $460. Okay, so we are going to find the slope, and I'm not going to write it again. I'm just going to subtract my y's, 460 minus 380. Subtract my x's, 800 minus 480, okay, which ends up with 80 over 320. And 80 divided by 320 is 0.25. Okay, what does that represent? The same thing, I can look at what I actually have in my slope formula over here. You're going to notice on the top here, that's my cost. The bottom is the number of miles. So this 25 is the cost, the dollars per mile. Okay, so it means that it is, the slope is 0.25, and that means 25 cents per mile. and it's cost per mile. So I explained what it is and what it represents. Now I need to find the y-intercept and say what that also represents. So if I use, and we'll use the first point again, 480 miles, cost $380. All right. Well, it's 25 cents per mile. So 25 cents times 480. Okay. Is $120. So it cost $120 for the mileage, but the total was $380. So I got to do 380 minus 120, which gives me 260. So my y-intercept is 260. Okay. And notice how it says at the top the monthly cost of driving a car. So y-intercept is 260, and that's going to be the one-time cost of the car, or just the cost of having the car. It's the cost for 1 month. It could be your car payment. You could write it as that. So now we're going to express the monthly cost C as a function of the number of miles driven. Okay. Well, when I think of y equals mx plus b, all right, we've already got our m is 25 cents. Our b is 260. All right. So if I wrote in mx plus b, it'd be 0.25x plus 260. Now I just have to go back and I want to replace my variables. So now it's saying the monthly cost C and the number of miles driven. Well, there's my miles driven. So that's going to become D. And my Y is my cost. So that's going to be C. I'm just going to rewrite this with my new variables. C equals 0.25. Sorry, my stylus is acting up. D plus $260. And that's my equation. Now there's one more part to this last one that I added. Use part C to predict the cost of driving 1,500 miles. So if I use my equation, C is 25 cents per mile plus the 260. What if I drive 1,500? So what if D is equal to 1,500? Well, that's pretty easy to figure out because I just have to substitute it in. 25 cents times 1,500 plus $260, which is 375. I don't know why this thing is being so stubborn, but try again. 375 plus 260, which comes out to be $635. So that would be the cost for driving 1,500 miles. Okay, so hopefully this helps with your understanding how to model a linear function or write in slope-intercept form. What you need to do if you would like to make up the exit ticket, there are 2 practice problems. Okay, over here, they're number 1 and number 2. You can print this, or you can do this on a piece of paper and take a picture and submit it, whichever is easiest for you. They It's also a Word document if you want to type it into the document, or excuse me, a Google document. If you prefer to do that, you can submit it that way. But you want to get the practice problems done and submit them to make up for the exit ticket. Okay? Let me know if you have